Hello guys, in the previous video we managed to solve the day 9 of the Advent of Code 2024, and in this video let's jump to the day 10. And without further ado, let's jump to the puzzle. So, day 10, Hoof It. You all arrive at the lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose probe your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book-titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you are about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, your puzzle input, and looks up at you excitedly. Perhaps you can help fill in the missing hiking trails. The topographic map indicates the height at each position using scale from 0 to 9, highest. For example, like this, okay. Based on your unscorched scraps of the book, you determine that the good hiking trail is as long as possible and has an even gradual uphill slope. For all practical purposes, this means that the hiking trail is any path that starts at height 0 and ends at height 9, okay? And always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left or right. Okay. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts on one or more hiking trails. Here, these positions will always have a height 0. Assembling more fragments of pages, you establish that the trailhead's score is the number of 9 positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1, because it can reach a single 9. This trailhead has a score of 2. And dots are impassable tiles. Okay. This trailhead has score of 4 because every 9 is reachable via a hiking trail except 1 immediately to the left of the trailhead. Yes. This topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. Here is larger example. Yes, this larger example has 9 trailheads. Considering the trailheads in the reading order, they have scores 5, 6, 5, 3, 1, 3, 5, 3, and 5. Adding these scores together, the sum of these scores of all trailheads is 36. Okay. What is the sum of the scores of all trailheads on your topographic map? Topographic map. Let's see. So this is our map. And let's split it up as usual. We should get the value of a list of strings. Yes. And what we want to do is there is 2 options. We could locate either the zeros, so the starting points, or the 9s. I guess it's easier if we go from 0. And so if we locate first all the zeros, we could even sketch it here. So if we first rule or whites first find all 0 values and locations Then we will do recursive, or recursive is one way, but I think it's the best way here. Recursive pathfinder. And from that we want to have how many trail heads. Yes, how many trail heads each start position had as, and then we need to sum them. Yes. So I think we can start building it. So what we want to first know is that all positions of zero values. And we can do it so that we have list of positions, starting positions, and maybe we can do so that we will create data class for these locations. Data class start position, and then there is x which is in the integer, and then y which is integer. And to get these, we want to do a for loop index item, or actually we can do, yeah, I think it's yeah, find it's row, and this is, since it's the row, it's the y value in map, and we want to enumerate the map. Yes, so we will loop through the rows. And I was thinking that if the y axis goes out, we have from in the left, top left, we have the 0y 0 x, and then we will start to kind of move towards the bottom right. And to locate the zeros, we need another for loop which has the x, and then number, let's say, in enumerate row. Now I need to check that can we, since row is string, I can't recall, could we enumerate a string? I guess we can, since it's not erroring out. Yes. Very good. So it should work. And then what we just check, if number equals to 0 or does not equal, then we will just do continue. And then if it does, we will create new starting position, which will take x as an x and y as an y. And if we run this, yes, we should have now starting positions available. Okay, no. So what we get? Oh, it was intended wrong. Okay. Now we should have. Yes, good. Wonderful. And now we know which are the starting positions, and now we can start to build our function. So we want to, so it was directions where so that every time it needs to increase by 1, but the directions are limited to only up, down, left, and right. Okay. So find next steps. And we could give it the position like this, and then height. And as we know that that we need to check left, right, up and down. I think we can first start by creating a steps array, which we will return in the end. And then if we check first for the edge case, if y is, wait a moment, we need to check first that if we are handling for first or last value of y and x, or maybe we can do that edge case later on. But let's actually think a bit. So we need the map here. So if we get should we first create the possible y, and if we create it, it will be basically y minus 1, y, and then y plus 1, and then same for x. So now we have the list of possible positions that we need to maybe check. Then if we look through for position y pos in possible y's, and then we get the if map y position, and then we can just use the x, and this needs to be equal to the current height plus 1. So if it is equal to that, then we can add steps append what we should have there. Maybe we don't need the current height because we can get it. Height is map y and x. So we can just add a tuple of or maybe we can rename this to be just the position. And then we can just do here at position. X is X and Y is YPOS. Yes, and then we need to do the same for possibly X. XPOS, height X, POS, and then Y. So now we loop through. First we check the current positions. Actually we don't need even this current position here. We just need possible Y's and X's. And then first we loop through the Y's. So we go for the upper row and then the row below, and then we loop through the X's. So it'll stay in the same row as we are currently, and then check the previous and letter value. One thing we want to check here is that if YPOS is below 0 or Y position is over or equal to length of this. So basically if we are going over the limits, or sorry, not that, just this, then we continue. And then same here. So if the XPOS is below 0, so we would try to go to the end of the row, example bit -1, and then if the XPOS is equals to the current row we are in, then let's continue. And I think this should be good. We could now try to run this. So let's have a for loop for POS in starting positions, but let's actually limit it to be the only one, or let's say first ones, and then let's get the next steps, find next steps. Actually we can convert this to be just the position, and now we need to actually refactor this a bit, but I think we can just do it here and then Y. Yes, I think now it should work. And then if we just print here the next steps, we should get, oops, yes, of course we need to give the parameter. And can only concatenate string, not integer. Aha, yes. This needs to be integer as well. Okay, so do we have actually any values yet? Okay, no. Let's take the first example here. Then to get just a little simpler data set to work with. Or actually, let's not do like that. Let's just first map this example. So then we don't need to refactor the whole thing. Okay. Oops. Of course, it helps or would help a lot if we would return the correct value. And let's see. So what we will have here, possibly X, and then if we print both here. Okay, that looks in the sense good that since we example have the first here, we can see that the possibly Y is 1 and 3. Actually, that looks a bit off. So if we just give it X and Y. So 2 and 0, correct. So potential values for Y should be -1 and 1. Oh, I did them in the wrong order. Okay. Let's make it so that it's easier to... Yes, that looks good. And then 1 and 3, yes. Okay, that looks good. Okay, so where we are going wrong? So if the current height, what is the current height? It's 0, yes. And if the Y is below 0 or Y position is equal, so does it even go here? So if we add or print out the... I see. Yes, so it tried to compare with string and integer and no luck. Yes, now it should work. Yes, correct. And now we actually got the next steps. So what we could do is that we will call this as a recursive. I'm wondering that should we then make this as a list. So if this is a list, and then we would have for positions, we would have this, and instead of returning steps, we would have reached. So we are basically reached trailhead. We could do either a list or we could technically also just return a sum. But since we want kinda to, so we want to have trailhead count for each starting point. Okay, it should go quite nicely. And then maybe the reach trailhead count actually. This can be 0. And then every time there is normal like thing, because if we now call this like this, and then we give the steps, and if this would return an integer, is it then like this? Yes, I think. And then if we, let's first check what it prints just with 1. And we need to convert this to be position, yes. 0, okay. So it will go, how many times it will call? It will actually, so we need to add also here a check that if current height is 9, then we can return 1. But if it returns and we have multiple, or actually it's reached head count plus equal. So if we have a case that we have 8 and then we have multiple 9s around it, we need to figure that out. We can continue, and then if there is some steps that we need to go through, then it's fine, otherwise we'll just return. Okay, and before we call this, we need to check that if we have steps. If we don't, then it's no point to call. How does it look? Okay, now it says 20. I slightly doubt that. Because it should be 5. So let's see how many times this gets called. Print. And then which were the positions. So we have first position of 2 and 0. Correct. Then we have 2 and 1 and 3 and 0. Now, because 0, but why? Why it adds this one? Position X. Because this is correct, but this is not. Let's see. Clearly it's, I think, because we are in the X3, we should maybe check this. Okay, so it's not added by that one, it's then added by this one. No. Aha. I think I know now. So we need to, I think it's somehow now there is this pointer to the variable steps passed. So I'm wondering that if we do positions, but this is not modified, it's just red. Let's actually do the passing here, or the copying here, sorry. Okay, now we have still the same issue. Let's add some additional logging, and then so both are adding that one. So how it gets then This is interesting, yeah, definitely. So it was not copy or issue with kind of this pointer thingy that I was suspecting. So if we print the possible y's and x's, it is -1, 1, and 1 and 3. So that 3 is somehow in the y, or sorry, x. Y. Yeah, it would ease up if I would have the correct print. Somehow didn't catch that one. So why it's saying the 3? Okay, it's working correctly. Yeah. Okay. So where is it going then? So we clean it a bit, then we run. Rerun the thing. So we get the 2 1s, and then we get that both are going to the same direction. 3 and 1, okay. Yes, it's the next one. Then 3 and 2. Yes. And then 3 and 3. Correct. But also 2 and yes, correct. Then 2 and 3. Yes. Then 2 and 4. Let's see here that reached, and then let's height, or we actually know that one anyways, and then current position. X10, yeah. Then X0, Y3. So if we would have the whole thing like this, and then just head count, and then do it like this. Let's print these, rotate these prints out. So we have or maybe this is okay. So how many times? So we indeed have quite many. Considering the trail heads. Is there same? Aha, okay. So there is same ones multiple times. So actually I think we need to return the positions instead. So if we just do, so that will append position, and or maybe if this would be a set, was it so that if we have a set, let's try, can we use this position x1 and y1, Add. So how about then just double, and then if we will add multiple ones, and then let's just one like that, and then okay, so this works. So we could, instead of position, we could do this one with doubles, and let's just use X and Y. I think it should be okay. And then if we, let's just try that if we have a one with A and one with B, we can do, or was there some maybe union, but let's see. Yes, so is it update, and was it in place? Yes. So we need to then just call dot update with this, and I think then we just need to here check the length. Okay, now we are talking. Yes. Now it looks good. So if we just remove that one and then run it again, we get 5 correct, 6 correct, 5 correct, 3, 1, 3 correct, 5, 3, and 5. And then if we sum them together, we will have the result of 36. Yes. So now let's run the original dataset and get the result from that. 36. I'm somehow doubting that. Yes, 430. Let's try this one here. Yes. One called star. So this was the part one. Quite simple in the end, after we just figured out the small detail to count only the unique positions. So let's continue to the part 2. So in the part 1 we needed to calculate or count how many trailheads we can find. And this part 2, let's see. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead called its rating. A trailhead rating is a number of distinct hiking trails which begin at the trailhead. For example, the above map has single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails which begin at that position. Okay. There is a map containing single trailhead with rating 13. This map contains a single trailhead with rating 227 because there are 121 distinct hiking trails that lead to the 9 on the right edge and 106 that lead to the 9 on the bottom edge. Here is the large example from before. Considering its trailheads in reading order, they have ratings of 20, 24. The sum of all trailheads rating in this larger example topography map is 81. Actually, I think we solved this in the part 1. Yes, and I think we can just copy this code. Yes. And here, instead of having set, we want to have that list. And then we want to append that position of x and x, and then y and y, and then append, or actually not append, we want to set it to be 1. Or we can do it actually like that as well, because or actually this will need to be like that, I think. So let's see our example. So if you want to try out with the example first, let's run that, then this, 81, we got that. And if you want to just check the individual counts, we can do it like that. Let's calculate the lengths. It's 2024 10 414585. Yes, correct. So then we can just remove that one. So now we will run again with the production dataset like so. And wait a moment. You want to run that one, and this one, and then this one. Yes. So 928. Let's see, is it our answer? Yes. Wonderful. This was relatively quick one. So now we have completed the day 10. I hope you liked the video. If you liked, drop a like, leave a comment, subscribe the channel, and see you guys in the next one. See ya!